Welcome back to the second part of the revision. We're going to take a couple of other questions, but please, you try to adjust the quality of the video you're watching, okay, on your phone. So there's a place there for options on the videos. You tap and then you try to do the arrangement so that you can be able to see the video. You can be able to have a better quality, okay. So we'll continue from where we ended. I think we ended on which question did we end in? Sorry? We ended on question 92, right? We said in a vacuum and in the same region, okay, all things fall in the same manner, okay, everything falls in the same manner in the vacuum. So, because the condition is the same, the conditions is the same for every object, okay. Now, where there is no air resistance, okay. Actually in real life, I think there is a question that we saw that two bodies A and B, not to of mass m and small m, where m is a capital M greater than small m, okay, in the absence of air resistance, okay. And I did tell you that if something that in free fall, okay, that been brought without any initial speed, it means that S equals what? Ut plus half at squared. Now, when you're dropping something, okay, at a height without any initial velocity, it means that U becomes what? 0. And S will be the height now that is going to cover with time. And what? A is going to be G, right? Yes. Half gt squared. So you see that the distance that thing travels at a particular time depends on what? Gravity and time. It does not take into consideration the mass, it does not take into consideration air resistance or anything of the particle, right? So in the absence of air resistance, in the same region, two bodies, you have a strand of hair and a very big stone are going to land on the floor at the same time. Okay? Alright. Then the next part of the next question, question 93. It says an elevator has a total mass of what? 1.8 tons. Okay? Remember, 1 ton is equal to 1,000 kilograms. It has a total mass of 1.8 tons. At the start of the ascending phase, the resistance to displacement is equivalent to what? 12% of its weight, and its acceleration has a value of 0.2 g. G is acceleration due to gravity, and I have been given the value the 9.78. Okay, due to gravity, G equal to 9.78. The magnitude of the tractive force exerted by the cables is, okay, because now it's so they say at the start of the ascending phase, so the elevator is moving upwards, okay. So what's the equation of motion? Let's say this is the elevator, okay. Now the weight of the elevator, mg, is acting downwards, right? Okay, and then it still has a resistive force, okay, maybe due to friction or something, that is also acting downward, which is 0.2 what? Which is 0.2 g is its acceleration. So what? Alright, now they said the resistive force was 12% of its weight, right? So 12% of mg, okay, which is the same as 0.12 mg. Not to 12% is the same as 0.12, right? 12 divided by 100. It gives 0.12 mg. Okay. Then now we have the tractive force, okay, is what is pulling it upwards, okay, from the cables. We have the tractive force F, which is pulling upwards. So it means that the total equation for this thing to be able to move upwards, okay, the total equation of motion for the elevator is F minus what? Mg plus 0.12 mg equal to what? MA, because this is the force that is trying to pull it upward, this one is resisting, so they are in opposite direction. Now the difference between these two forces is to this an acceleration. Okay? Now we are going to say that G is so from here you see that F equals to what? Mg, M times 0.2 G now. We already told that the acceleration is 0.2 G plus Mg. In fact, this one is 1.12 mg, right? Okay, this one adds up to 1.12 mg now. So mg plus 0.12 mg adds up to 1.12 mg. Okay? Implying that F should be equal to what? Now this one will give us 0.2 mg plus 1.12 mg, which will give us 1.32 mg, right? Now what's the weight? What's the mass? Sorry, the mass is 1.8 tons. So 1.8 times 10 to the 3 kilograms, right? Times what? Acceleration due to gravity is 9.78 in this question. So please look at the question well before you do anything. Okay?
So tons is equivalent to kilograms.
1 ton is 1,000 kilograms. That's why I'm writing 1.8 times 10 to the 3 kilograms. Please, you should like and share to your other friends, I beg. And if you are not subscribed, you should subscribe fast. So I think I can write. Okay, so the equation says that two seaboards B1 and B2 are allowed to fall from the same horizontal plane at a height of 25 meters to the ground. At the initial moment, B1 is released without speed, whereas B2 is launched with a... So B1 is released without speed, meaning that for B1, okay, its initial speed, that's U is equal to 0, okay? And so it's this after 1.5 seconds in height, okay, above the ground, that's we apply the equation S equal to ut plus half at squared. Now it's moving under gravity, not to initial speed is 0. So for B1, its height above the ground is going to be, we are going to have, so the distance it must have covered is going to be half g t squared, not to. Alright, which you can substitute half into what? You can consider g to be 10, and then this one is 1.5 seconds, okay? Squared. You can have an answer, okay? Then for B2, what were you told? They said for B2 is launched with a horizontal speed of 5 meters per second, okay? So horizontal projectile, not to. So it is launched with a horizontal speed. Remember, for a horizontal projectile, not so this is going to be like, okay? So for a horizontal projectile, U, so for him, U is equal to 5 meters per second, okay? And then what happens? The initial angle alpha is equal to 0 now, or angle of projection is 0, and then you have what? Uy, okay, initial speed is 0, not so vertical speed is 0, because for projectile we need to separate the horizontal speed from the vertical, okay? And so here we have Uy equal to 0. Uy is the initial initial velocity, vertical velocity, right? It's equal to 0. Because normally if you're projecting it at an angle, okay, we have to have what? If you have alpha, you need to take if this is U, you need to take U cos alpha and U sin alpha. This one will be Uy and this one is going to be Us, okay? But all along this thing is going to have an initial speed of what? U, okay, and this initial speed is simply the horizontal speed of the projectile. Is it okay? Now this stuff is still going under gravity, right? The thing is going under gravity. So it means what? Sx, xy, sorry, the vertical distance, no, we're looking about the vertical distance that is covered above the ground, the distance above the ground, okay? Sy is the same as what? Uy times t plus what? Half ay, okay? T squared. Are we there? Now initially, this thing has no initial vertical velocity, right? So it means that Uy is 0. And so the height above the ground will have, this thing is moving under gravity, right? Okay, so the vertical acceleration, that's AY, is equal to G, which is G times what? T squared. So they have the same time, not to. So although this one was projected horizontally with an initial speed of 5 meters per second, and this one was dropped initially without initial velocity, according to physics, you see that they are going to have what? The same height above the ground at a particular time. Is it clear? Yes.
So I feel like at the beginning of the motion, the horizontal speed is equal to the vertical.
No, they said horizontally. Check the equation. They say it is launched with a horizontal speed. So when you launch something to the horizontal motion, I'm going to give you a condition. Angle is what? 0. U is equal to 0. Initial vertical velocity is equal to 0. Okay? They give the reason why they gave the equation like that. So what's the answer? See now. The height of the ball are equal. (95). The work done by a force perpendicular to displacement is what? Is 0, right? Imagine I have a body like this, not so. This thing is moving in this direction, okay? And then you have a force that is acting over in this direction, right? Now the force that does the work, okay, is the force that acts in the direction of motion. If you are acting perpendicular to the direction of motion, it means that you are practically doing no work, okay? You are not going to do any work, so it's going to be 0. So if you are perpendicular to the direction of motion, the force is useless. Is it okay? Yes, so the answer is none. C. There's a question 96 to 99. Okay, we'll follow this particular question, right? They say a ball is thrown from a point O on horizontal ground with a speed v0, inclined at an angle alpha. Okay, so it is thrown on horizontal ground. Okay. So it is thrown on a horizontal ground also with a speed that is v0, that is inclined at an angle alpha to the horizontal. Okay. With respect to the horizontal, neglecting air resistance and considering the ball to be what? A point mass. Okay. So obviously this is going to be a projectile, not so. The thing is going to move in this manner. And you are going to have a vertical component and a horizontal component. So they said during the motion of the ball, okay, the acceleration vector, okay, remember for a projectile there is no horizontal acceleration. How do you know that? Throughout the motion, the speed remains what? The horizontal speed remains constant. Is it clear? So the horizontal speed I calculate initially from here, which is equal to ux equal to u cos alpha, okay, will remain constant till the end. Okay? Why? Because there is no horizontal acceleration. But the vertical speed keeps on changing. Why? Because there is a vertical acceleration, right? Now you see that the acceleration when this particle is moving like this, not so, is going to be what? Negative g, right? It is moving against gravity. Are we there? Now what happens when it reaches the top? Not so, and then it starts coming out. What happens? The acceleration changes to what? To g. Okay, so when it gets to the maximum point, when it starts moving and the acceleration changes from negative g, since it was going here, is going against gravity. Here is going under gravity. Okay, so the answer there is the acceleration vector changes direction at the apex of the trajectory. Okay? Are we d'accord? Good. It changes direction at the apex of the trajectory. So we mean that here is negative g and then, okay, it starts going to g. Are we there? Then next part, next option or next question. So the answer there is D. 97 says at the summit of the trajectory, the speed is what? Sorry? No, the speed cannot be known. No, the speed cannot be the maximum because at the trajectory, not see at the top here, not to. Remember that normally you can say V of anything can be given by what? Square root of Vx squared plus what? Vy squared. Are we together? So when you get to this top here like this, okay, Vy becomes what? 0. Okay? So by the time you're here, not to, you have an initial which is equal to ux, okay, ux plus uy, other square, not to. Then when you start moving up, okay, what happens is that what? This Vy starts what? Decreasing. Alright? Because you are moving against gravity. So Vy starts decreasing. But now since it's decreasing, what happens? You see that at the end, at the top, not to, at the maximum point, at h max, okay, remember Vy is equal to 0. And if Vy is equal to 0, it means that V becomes what? Square root of Vx squared now, which will be called simply equal to Vx. Are we there? So at this point here, and this is what? And remember Vx is the same as what? It's the same as Ux now. Because as I said, the horizontal velocity does not change because there is no horizontal component of acceleration. Okay? So what happens? It means that at this top here, the speed is just equal to what? It's just the horizontal speed, and it's the what? The minimum speed that you're going to obtain along the trajectory. Is it clear? Because remember, see, look at from here. You start from here, right? As you are going, what happens? This one is decreasing now. You finally get to there. When you now start going back down again, what happens? You start having V starts increasing again, right? Okay, so it means that this one now will start increasing again. So the minimum speed you are going to have is when you are at the maximum trajectory. Is it clear? Okay. So just know that when you are at the maximum point, Vy is equal to 0, and you have just a horizontal component of velocity. Okay? Then 98. So our answer there is C. 98. The height of the trajectory at the summit is what? They are asking for H max, right? What's maximum height? What's the formula for maximum height? H max. U squared sine alpha. If you are starting with alpha, you use alpha, okay? Or 2g, okay? On 2g. U squared sine alpha on 2g, okay? When you want to have the maximum height, what do you do?
I think it should just be U square over 2g.
No, this is if it is not a projectile. U squared on 2g is when it is not a projectile, okay? If it's vertical motion, right? If it is vertical motion, you see it will be U squared over 2g, okay? But if you project it at an angle, okay, it means that you are dealing with a projectile, so there must be an angle there. So let's look up. So you see that U is the initial velocity normally, okay? This is the formula. So they said that the option, they say the height of the trajectory at the summit, okay, that's the maximum height, is independent of V0. It cannot be independent, right? Because in this case, V0 is our initial velocity. So if you are to write the formula for this case, it means H max should be equal to what? V0 squared sine what? Alpha over 2g. Okay? B says independent of the angle alpha. Is it possible? No. Okay, it depends on the initial angle of projection. Then C is proportional to V0. Sorry? It is proportional to the square of V0, not to V0. Okay, so the answer there is what? E. Okay, it's proportional to the square of V0, not to V0. Because if you are saying that V0, okay, it means you are ignoring the square sign. Alright, that's why your formula is important. So you see that in this case, it is not need to solve, right? You just need to apply just your principles and you're going to be okay. Okay? Please, if you guys are having a good quality of video, write in the comment section below. Just indicate on the comment section, let me know. And try to see if the problem is at my end. Okay? 99. A car moves at a speed of 90 kilometers per hour. To which height should it fall without initial velocity to attain the same speed? Okay? Please, are we done here? You just need to understand, okay? The main thing that you need to understand here was your principle, okay? Like here, you needed to know the formula, and then here you need to know about the reaching maximum height. You need to know that, okay, maximum height dy is equal to 0, okay? And things like that. Now let's go. They said a car is moving at what? 90 kilometers per hour. I said if you have to convert speed from kilometers per hour to meters per second, what do you do? From kilometers per hour to meters per second, okay? You multiply by 5 on 18, okay? So the 90 v equal to 90 kilometers per hour is the same as is equal to 25 meters per second, okay? So they are saying that the car is moving at what? 90 kilometers per hour and 25 meters per second. To which height should it fall without initial velocity to attain the same speed? Okay? So if we place this, if we take the car, not so, and place at the point, right? And allow the car to fall with u equal to what? 0. Okay? To which height should this thing fall to have the maximum speed, to have a speed of 25 meters per second? Okay? Here, you see they're asking us about final speed, right? So you cannot use the equation s equal to ut plus at squared, okay? Because you will not be able to deal with the maximum speed there. So it means that you are starting with 0, but your final speed is what? 25 meters per second. Is it clear? So what we are trying to say is that we can use the equation v that relates all of them. V squared equal to u squared plus what? 2gs. Is it clear? Or 2gh. Let me put it like that. Now the normal equation is v squared equal to u squared plus 2as. But since our acceleration is g, our falling under gravity, our s, distance covered is rather the height falling. Okay, that's what I'm putting it there. Okay? So what they are looking for is h now. Now we know that u is already equal to what? 0 because they say it should fall without any initial speed. Okay, so it means that h should be equal to v squared over 2g. Is it clear? Which should be 25 squared divided by 2g, right? That's 2 into 10. Now please, I hope that you see that this one is maximum height. Okay? It's like it's a maximum height. There we have what v squared or u squared. Now although this one is maximum, sorry, this one is the final speed, okay? But we have something like u in the initial, then since this one is vertical, that's why I'm not having any sign. Okay, you're not having the sign of any angle involved here because they are doing vertical motion. Okay, so what's the answer? 31.25 meters. Okay, so it means that it should fall from, okay, if it's falling without any initial speed, it should fall what? 31.25 meters to have the initial speed of, sorry, to have the final speed of 25 meters per second, okay? To attain the same speed, 90 kilometers per hour. Is it clear? Alright, good. Let's move on. Question 100. The electrical energy WE received by a receiver whose terminal voltage is what? 3.0 volts, where it is traversed by a current of intensity 1.0 amperes to 20 milliseconds is. I'm sure I've answered this question somewhere, right? Yeah, in one of the years, maybe 2016 or so. Okay, those years we answered it somewhere. So, what do we know? Energy is equal to power times time now. Power is given as what? IV. Okay, so IVT is equal to energy. So the current is 1.0 amperes times what? Voltage. 3.0 volt times time. 20 milliseconds now. That's 20 times 10 to the negative milliseconds. What's our answer going to be like? is 0.06, right? Which is the same as 6 times 10 to the negative 2. Our answer is C. Okay? Our answer is C. Please, even after we end the class, you can always go back to rewatch the video. Okay, that's one advantage, that is that the video is going to be there with the same explanation. So if you, in case you don't understand. Okay, let's without wasting much time, let's just go to 2019. Okay, physics 2019 at once. I'm the one that answered chemistry with you guys now for this one. I mean the people that are in Boyan. Physics 2019. 76 is the method of dimensions. The method of dimensions it doesn't tell you when the equation is wrong. Can be used to derive an equation since it has nothing to do with the units. Okay? Now, when you have dimension also, dimension is just part of what will tell you that an equation is correct. Okay? So if you can actually take an equation, for example, and just like you are using base units and dimensions, right? So if I take the equation, for example, S equal to what? Ut plus half 80 squared. Are we there? And then I write that S equal to what? Ut plus
1/3.
even 1/3, okay, you can change it to 1/3 80 squared. Using the method of homogeneity, not to. This thing is what? Is correct. Or using dimensions. If you use dimensions will be okay. But it will not tell you that the equation is wrong. Is it clear? It cannot tell you when the equation is wrong. So for it, because there are constants in the equation, okay, that you derive by other methods. Is it clear? So the answer there should be what? A. It doesn't tell you. So a dimensionally correct equation, okay? Equation which is dimensionally correct is not necessarily a correct equation. Okay, because there can be some constants there that maybe was added or was removed, which cannot actually be determined by the method of dimension. Okay? Those constants are dimension, most constants are dimensionless. Let's go to question 77. Consider the diagram below. So the bulk of the single pendulum is set in oscillation. If the string cuts when the bulb is passing through B, okay? When the bulb is passing through B, A, the bulb will fall vertically from point B. Please, one thing you should know is that this is for circular motion, not so. That pendulum that you see there, okay, at one point is going to be here, okay, and another point is here. So you see that is what? It's doing simple harmonic motion, right? Okay, and in the arc of a circle. And if you remember that if something is going round in a circle, okay, at the moment that the string cuts, okay, the thing is going to what? Travel at a path which is what? Tangent, okay, tangential to its path. So it means that if it gets here, the string will go, okay, at the path which is tangential. Are we there? So it will be like a horizontal projector if it gets here, okay? Now if it gets at this point here, also, this thing is already on the diagram up, right? It's going to get at the tangent, okay, meaning that the thing will be projected, okay, in this manner before moving like that. Okay? If this thing is coming so and it gets here, okay, it's going to what? It's going to move at the tangent. Are we together? Right? It's going to move at the tangent. Are we there? At any point. So when something is moving in a circular manner, okay, when the string cuts, the particle is going to move at the point which is what? At the point which is tangential, okay, to to its part at that to the point at which the ball was at that point. Is it clear? So if that is true, so it means that if this particle is going to perform horizontal motion, okay, horizontal projectile. So they said the bulb will go beyond point C before falling. Okay, this is point A, this is point B, and this is what? Point C. So this bulb will not go beyond point C. Okay, you will not move up like this because remember you are here, right? So you are going to go at the point to tangential. So you rather undergo what? You rather describe what? Horizontal, the path of the horizontal projectile. Is it okay? So they said the path described by the bulb will be given by what? H equal to gx squared over 2u squared, where h equal to height of the bulb, u equal to that. Please let's start it. If this thing starts from here not and travels, remember if it's horizontal projectile, initial angle theta or alpha is equal to what? 0. Uy is equal to what? 0. Okay? And your level just what? Ux now. So what happens is that it's going to have an initial speed here. You live with an initial speed u, right? And equation of path y is equal to what? Y is equal to x tan alpha minus what? Gx squared sec squared alpha divided by 2u squared. Is it okay? 2u squared. So remember our angle is 0, okay? So our height above the ground, if h, y is our vertical distance h, x is what? Now we don't know x not to, but alpha is 0 now. That's the initial angle of projection will be 0. So tan 0 is 0. So they will be left with negative gx squared into 1 plus 1 plus tan alpha, not to tan squared alpha. Sec squared alpha is the same as 1 plus tan squared alpha divided by 2u squared, not to. So h should be equal to negative what? Gx squared. Are we there? Tan 0 is 0. So we will be left with gx squared times 1, which will give us gx squared, right? Over 2u squared. Now you can take the magnitude. Is it okay? You can take the magnitude to have your height above the ground at a particular time. Are we together? So our answer will be what? C. The path described by the bulb will give h equal to gx squared over 2u squared, where h equal to what? Height of the bulb, u equal to horizontal velocity of the bulb, and x equal to horizontal distance traveled by the bulb. So C is correct. Yes.
So I thought that now at point B, there's no fall that's going to cause a bulb now to maybe move towards any direction.
No, it is a principle. That's why I said, okay, if someone is moving in a circle, when the rope cuts, it moves what? At the path tangential at the point where the rope cuts. Is it clear? It's a principle. If I take a stone and start turning it like it's not so. If the stone cuts at this point here, alright, at the point where when the bulb is at the lowest point, you will travel horizontally, okay, you will come towards me.
So I mean that now, like, say you suspect it's not.
Don't think about it. Don't think about it. How can I say?
Real life.
Yeah, don't. The thing is moving like this, okay? It's moving. So you are not just suspending at one point. No, it is moving like this. Okay, it's swimming. So in case and it is here, then the thing gets, you just go straight. Okay, because there is a force of gravity that will control this thing. 78. The graph below represents the variation of energy with time. For what?
Ball bounce.
No. A ball that is bounced on the floor, not so. If you bounce the ball on the floor, what happens? Okay? The energy will decrease with time now to what? 0. Is it okay? But here you see the potential energy and the kinetic energy what? They are constant, okay? Over time, and the mechanical energy is constant. So that's what? Simple pendulum, okay? That's a simple pendulum. Typically, you should not even pay that question. That's typically for a simple pendulum, okay? So for a simple pendulum, not as it's oscillating, right? Remember, when at its maximum position, okay? This is a simple pendulum. When it oscillates and gets here, right? Potential energy is maximum. Is it okay? So from the graph that we have here, let's say when potential energy is 0, when it's at equilibrium position, kinetic energy is what? When it is at this point, right? K is potential energy here is 0. Here, K is what? Maximum. Is it okay? So K is going to be maximum instead. Then the opposite will occur, right? Just like that. Is it okay? But the total energy in the system remains what? Constant. Mechanical energy remains constant. Okay? Because mechanical energy is equal to Ke plus Pe. So at any time t, when you add a K and a P, they will always come up to give you a constant. Okay? Because at this moment where kinetic energy is now P is 0, here K is what? Is 0. Why potential energy is what? Maximum. Okay? Just like that. So maybe at this moment some fraction of the energy is kinetic and some is potential. They will always add up to give us the mechanical energy. Okay, that was a single pendulum. Okay? Now for a ball that is oscillating in a windy area, okay, if the area is windy, it means that okay, at one moment the energy will increase because the wind will tend to move it. Okay, this one you see the energy is constant, there is no variation in it. Okay, it is the please I made a mistake here. The energy does not go below the x-axis. Okay, either it reaches 0, one will reach 0 and go back up to maximum. Energy will not go below the x-axis. Okay. Next option 79. My next question. Two perfectly elastic identical cells traveling in opposite directions with the same mass and same speed of 0.01 kilograms and what? 30 meters per second respectively collide head on a smooth horizontal surface. Which of the following statements about the motion is true? Okay. Now, what will be the total momentum here?
0.
Is 0 now? Now, look at something. I have two balls, right? They are moving in opposite directions. Not so. They have the same mass, the same initial speed. Okay, this one has a mass and an initial speed moving in this direction. Are we together? So it means that this one, the momentum of this one is what? Mu. Okay, this one will be. So consider this direction to be the positive direction and this one to be what? Negative. So it's mu minus what? Mu, which should be equal to, let's say Ma, we call this one A and we call this one B. Now I'm just using M here because they have told us that they have the same mass. Okay? So M times what? VA plus M times VB. Because we don't know how they will travel after collision. Is it okay? We don't know how they will travel after collision. But it's obvious that MVA plus MVB will be equal to what? 0. Okay, MVA. In fact, VA from here, M will cancel all through now. So VA will be equal to negative VB. Is it clear? VA will be equal to negative VB, meaning that they will still be traveling in opposite directions. But the momentum is still someone to give us what? 0. Is it okay? Now they said that the collide on a smooth which of the following statements about the motion is true. Then we can also apply what Newton's law of restitution. Okay? We say that the speed of what? Separation over the speed of approach is equal to a constant, right? So if I take VA minus what? VB over UA minus UB should be equal to negative E, right?
VB minus UA.
Please, if I use VA minus VB over